Hi, everyone. I just wanted to kind of go through the review sheet quickly, highlight a couple of important things. I didn't get any specific questions, so I'm just going to kind of go through it kind of quickly. All right, so some of the things that you need to make sure you know about logs. First of all, that logs are the inverse of an exponential function. So if they ask for the inverse of a log, it's an exponential function. If they ask for the inverse of an exponential function, it's a log. Now, you can also take that exponential form and put it in log form. Okay, so these are equivalent to each other. Let me get my little, I don't know if you can see my pointer here. Um, Hold on. So these are equivalent to each other, these expressions right here. This one and this one. Okay. So if it says put this in log form, this is it. If it says what's the inverse of this, then you would have to switch X and Y. Obviously, this is an ABC, but you would have to switch X and Y and then possibly put it in log form. So just be careful when you're reading those questions, which we'll see in a minute. All right, your log rules. So there's only 3 log rules, but you can use them in 2 ways each. So here you're condensing these 2 logs and making it 1 log. Here it is 1 log and you're separating them into 2 logs, right? So this is expanding it, this is condensing it, but it's the same rule. The rule is that when you have 2 logs with addition, it's equal to 1 log with multiplication. This is the second rule. Just use 2 ways. Condense it, make it 1 log with division, or separate it into 2 logs with subtraction. And then the exponent one, when you have log with an exponent, you can put it in the front and multiply, or if it is in the front, you can put it back as the exponent, right? So 3 rules, just each of them used 2 different ways. Okay, then we have the graph of a log. So some characteristics that we need to know. Let's see if I can scroll here. Okay, so some characteristics that you need to know. So things like the x-intercept, the asymptote. So we can see that no matter what the base is of that log, we're still going to have an asymptote that is the y-axis, which is x equals 0. They're all going to hit the x-axis at 1 comma 0. Obviously, this is before any kind of transformations. So if there's any shift left and right, that's going to change the asymptote, which is going to also change the here, which is also going to change the x-intercept. There is no y-intercept in these particular graphs, and that's because the asymptote is the y-axis. But if that shifts to the left, then you are going to have a y-intercept, right? So you really have to look at the equation to determine, what the domain and the range and the asymptote are going to be. So you can see here, if we shifted this to the left 5, the asymptote is now x equals -5. And the domain, therefore, has changed from -5 to infinity. The range is still staying the same because it's still going down forever, up forever in both of these kinds of shifts. This one was shifted to the right. The asymptote is x equals 1, so the domain is 1 to infinity. Okay, but the range still stays the same. All right, so just a couple of these questions quickly. I tried to put a little explanation on the answer key itself. But again, which is equivalent? So you're just putting it in log form in number 1. Let me just see. Hold on. Let's see if this works. Okay. So this is equivalent, right? So we're not looking for inverse here. We're not switching x and y. We're just simply putting it in log form. X is the exponent. So that is log. The base is 3. Okay. This one, we're just simplifying, put it into the calculator. This one